All right, so on page 385, number 5, we're going to take square root of 11 times 4th root of 11. But when we're multiplying, in order for us to multiply these, put them all underneath the same root, they have to have the same root. This has a 2nd root. This has a 4th root, so we can't do that. So we need to try, see if anything else will work. So let's try writing this a different way. Instead of writing it in the radical form, let's try writing it using exponents. So the square root of 11 can also be written 11 to a certain power. All right, keep in mind 11 is being taken to the first power, and it has the 2nd root. So the first power goes on top, and the root goes on the bottom. So this is the same thing. 11, the square root of 11 is the same thing as 11 to the 1/2 power. And we're going to multiply it by this one. 11 is being taken to the first power, but the 4th root, so we can write that as 11 to the 1/4 power. All right, the next thing is we have like bases that are being multiplied. So when you have like bases being multiplied, you keep the base and you add the exponents. For those of you that have trouble remembering that rule, you can always go back to PEMDAS. All right, because we always start by doing what's inside parentheses, exponents, multiplication, division, addition, subtraction. So when you are multiplying like bases, you will not also multiply the exponents. When you're multiplying like bases, which is here, to remember what you're doing with the exponents, you always drop a level. Okay, and then that means you're going to add the exponents. Continuing, 1/2 plus 1/4, you cannot add fractions unless the denominators are the same. So 4 and 2 both go into 4. So we're going to make that our denominator. So the second one did not change, it stayed 1/4. To change from 1/2 so that the denominator is 4, we're going to multiply the 2 by 2 to get there. And if you do that to the bottom of a fraction, you have to do the same to the top. So once the denominators are the same, when you're adding and subtracting, you keep the denominator and you work across the top. All right, now once you do this, you always need to kind of look and see, would that be able to be simplified? So to check that, we could then rewrite it as a radical, just to double check. All right, so we've got this bottom, remember that's the 4th root, and this would be 11 to the 3rd power. Since the 11 cannot be factored any farther, and we don't have 4 of the same thing being multiplied inside, you cannot simplify it anymore. So either answer is correct. Okay, you could leave it like that, or you could leave it like this. Either one or either answer. Number 6. All right, so when we're looking at this, the only way we can put both of these all underneath the same root is if the roots are the same, and they're not. So we're going to rewrite it. Instead of the 3rd root of x, I'm going to write that as x to the 1/3. And instead of the 6th root of x to the 5th, I'm going to write that as x to the 5/6 power. Okay, now, similar to up here, we have the same base, but it's being divided. So if you are dividing like bases, you subtract their exponents. So we'd have, you start from the top, 1/3 minus 5/6. Again, if you're adding or subtracting fractions, the denominators have to be the same. So 3 and 6 both go into 6. So the second fraction did not change. To change 3 to a 6, I would multiply by 2, which means I have to multiply the top by 2. When you're adding and subtracting, once the denominators are the same, you keep it and you work across the top. 2 minus 5 is a -3. -3/6 reduces to -1/2. All right. So let's look and see if this is in proper form. First of all, with the negative exponent, that's not good. Okay, so remember how this is really all over 1. And if you don't want a negative exponent, it's okay to take everything In a fraction, if you want to take everything on the top and move it to the bottom, that's fine, as long as you change the sign of the exponent. So we can move that to the bottom as long as we change the sign of the exponent. So on top, we're just left with a 1. All right, now, problem with this 1/2 down here on the bottom is, if we rewrite that in radical form, that is the square root of x. And this is not simplified if you have a radical on the bottom. So since it's a square root, that means we need 2 x's being multiplied down here for that radical to go away. So that will provide us with 2 x's. If I do that to the bottom, I have to do it to the top. So we multiply across the top, we get square root of x. Across the bottom, square root of x times square root of x. Keep in mind, that would be 2 of them. So these 2 would come out as an x. That's one way to look at it. Another way to look at it would be, if you have, since they're both square roots being multiplied, you put it all in underneath the same one. So x times x would be x squared. And a square root and a square, those 2 numbers, if they're the same, they're inverses of each other, which cancel each other out, leaving you the x. So that was another way to look at it. Okay. Anytime you have a square root multiplying by itself, you're going to get what's inside. All right. So that would be the simplified answer. All right, simplified, there's no radical on the bottom, so that's your best answer.